Good day, students. Today we will be having law of exponents for the American curriculum or index rules for the British curriculum or the International Baccalaureate curriculum, right? The first rule that we're gonna be discussing is what we call the product rule or the law of exponent number one. Law number one, product rule. It says that a to the power of m times a to the power of n is equal to a to the power of m plus n. That's it. For example, a to the power of, let's say, 2 times a to the power of, let's say, 4, that would be a to the power of 2 plus 4 is equal to a to the power of 6. This rule only applies if the bases are the same. Now let us try to prove whether that law is correct. Proof. For example, a to the power of 2 times a to the power of 4 is equal to a times a times a times a times a times a. This is your a squared and this is your a to the power of 4. Now we have a times a times a times a times a times a. So you have to multiply a by itself 6 times. So 1, 2, 3, 4, 5, 6. So we were able to prove law number 1. Next, let's go to law number 2, which is what we call quotient of a power. Quotient of a power, or the division rule. For example, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. Example here, we have a to the power of, let's say, 7 divided by a to the power of 3 is equal to a to the power of 7 minus 3, which is equal to a to the power of 4. So this law only applies if and only if the bases are the same. Now let's prove whether that particular law is correct. Okay. So our proof here is a to the power of 7 divided by a to the power of 3, which is also the same as a to the power of 7 over a to the power of 3. So we have our a to the power of 7 is a times a times a times a times a times a 1, 2, 3, 4, 5, 6, 7 times a divided by a times a times a. So we can cancel this and this and this. So this is times 1 times 1 times 1 times 1 times 1 times 1 times 1. So what we have left here is 1, 2, 3, 4. We have a to the power of 4 times 1 times 1 times 1 divided by 1 times 1 times 1, which is still equal to 4. Now let us proceed to the third law, which is what we call power of a power. So this is law number 3, power of a power. For the law says that if the power if exponent or of an index is raised to another power or an exponent, you just have to multiply their exponent. For example, here a to the power of m to the power of n. So we just have to multiply the exponent. A to the power of m times n or a to the power of m n. For example, here we have a to the power of 4, all of them to the power of 3. So that becomes a to the power of 4 times 3, which is equal to 4 to the power a to the power of 12. That's our answer. Now let's prove whether that particular answer is correct. So a to the power of 4 to the power of 3, that means you have a to the power of 4, you have to multiply to itself 3 times. So we have a to the power of 4, a to the power of 4 times a to the power of 4. So you have to multiply a to the power of 4 3 times, because that's what it means by the index or exponent there. You have to multiply a particular number by itself by how many times, right? Now, so we have here a to the power of 4, which is a to the power of which is a times a times a times a, right? And then times by another one, a times a times a times a, and then multiply again by a times a times a times a, which is, that means you're gonna have to multiply all of them a times a times a times a times a times a, and so on. So we have a total of 12, a to the power of 12. And now let's proceed to the next law, which is power of a product. Power of a product, law number 4, states that you have to distribute the exponent if two individual bases are being multiplied to each other. So we have a times b, all of them raised to the power of m. So what we have to do is we have to distribute the exponent to each of the factor. So we have a to the power of m, b to the power of m. All right. For example, we have a to the power of a times b, all of them to the power of 2 is equal to a squared b squared. Another example here, let's have another example here. A to the power of 2, b to the power of 3, all of them to the power of 4. So you just have to distribute the exponent, you just have to multiply it. So we have a to the power of 2 times 4, then b to the power of 3 times 4. So we will have a to the power of 8, b to the power of 12. That's our answer. Let's try to prove whether that answer is correct. Proof here. So we have a squared b cubed, all of them to the power of 4. So you just have to multiply a squared b squared by themselves 4 times. So we have a squared b cubed times a squared b cubed times a squared b cubed times a squared b cubed. So we have 1 2 3 4, that is a to the power of 8, and then 1 2 3 4 we have b to the power of 12. So we were able to prove the fourth law. Now let us proceed to the fifth law, which is power of a quotient. Fifth law is almost same as the fourth law, which is power of a product. Power of a quotient is you're just going to distribute the exponent to individual factor as well, or you're going to distribute the exponent to the numerator and also to the denominator. All right, let's try this one here. We have a to the power of m over b to the power of m. Let's have this one as an example. We have a to the power of a over b, all of them to the power of, let's say, 3. That becomes a cube over b cube. Now let us try to prove whether that particular law is correct. So we have a over b, all of them to the power of 3. So we have a over b times a over b times a over b. And of course, when we are multiplying fraction, what do? We multiply the numerator by numerator by numerator. So a times a, then times a. So that becomes a times a times a. and we have b times b times b. So when we are multiplying fraction, we multiply the numerator by themselves and we multiply the denominator by themselves. So we have b times b here. That will become a b cube, and the numerator we have a cube. So we're able to prove the fifth law. Our sixth law is the negative exponent. So we just have to remember that all numbers raised to the negative number, we just have to find the reciprocal of that particular number so that the exponent will become positive. Let's have this one as an example. A to the power of negative m is equal to 1 over a to the power of m. Let's try this one as an example. We have example a to the power of, let's say, negative 3. That becomes 1 over a to the power of 3. Now let's have this one as another example. We have a over b, all of them to the power of negative 2. So this is the quotient law. So the first thing that we need to do, we need to apply the quotient law. That means we need to distribute the exponent to both of them, right? To both the numerator and the denominator. So we have a to the power of negative 2 and b to the power of negative 2. But we have a negative exponent, so we have to find the reciprocal of a and then the reciprocal of b. So that becomes what? B to the power of 2 over a to the power of 2. So we reciprocate a to the power of negative 2 and we also reciprocate b to the power of negative 2. So we just have to put them up and we have to put the a down. Then they become positive exponent. Alright, let's have another example here. So we have this particular given here. We have a to the power of negative 2 times b to the power of 3. All of them to the power of c to the power of positive 4. Now the first thing that we need to do is we need to distribute this one. Correct? We need to distribute the exponent to individual given here. So what do we have here? We have to multiply the all of the exponents by negative 2. So we have a to the power of negative 2 times negative 2, and we have b to the power of 3 times negative 2 all over c to the power of 4 times negative 2. We need to multiply this to each of them. Okay, so let's try to answer that. So we have a to the power of positive 4, because negative 2 divided times negative 2 is positive 4, and then b to the power of negative 6 all over c to the power of positive 8. Now what are we gonna do next? Now this is our answer, but we only have one negative. Remember, in our final answer we need to have only a positive exponent as our final answer. So since only b to the power of negative 6 is our only negative exponent, so we only have to do something about b to the power of negative 6. So that means we need to find the reciprocal of b to the power of negative 6, which is, let's try this one here. Let's rewrite it here. A to the power of 4, b to the power of negative 6 all over c to the power of 8. Let's rewrite it. So we have a to the power of 4 over c to the power of 8, isn't it? Times b to the power of negative 6. Then we have to find the reciprocal of this one. That becomes a to the power of 4 all over c to the power of 8 times 1 over b to the power of 6. Now we can multiply them back again. We have a to the power of 4 times 1 is equal to a to the power of 4 over b to the power of 6 c to the power of 8. That is our final answer for the given there. Law number 7 is identity. Identity means any number raised to 1 is the same number. For example, a to the power of 1 is equal to a. B to the power of 1 is equal to b. We have x to the power of 1 is equal to x. And 2 to the power of 2 is equal to 2. And 1000 to the power of 1 is still equal to 1000. That is basically our 7th law of exponent. Alright, that means you don't need to write the exponent 1 if we're solving, or any time you get every time you get to see a variable without an exponent, just like this, automatically their exponent is 1. No question asked. If you don't see an exponent, it's automatically 1. If we don't see an exponent there, again, it's 1. Law number 8, zero exponent. Any number raised to the power of 0 will always be equal to 1. For example, a to the power of 0 is equal to 1. X to the power of 0 is equal to 1. And we have 1000 to the power of 0 is equal to 1. And 1 million to the power of 0 is equal to 1. For another example here, we have x, a, b, c squared, all of them to the power of 0 is equal to we have a to the power of 0, b to the power of 0, we have c, 2 times 0 is still 0. That becomes a to the power of 0 is 1 times this is still 1 times this is still 1, which is equal to 1. Alright? Now let us try to answer some questions here. Let's go with number 1 here. Number 1 is this one. We have a to the power of a squared times a to the power of 3. That becomes a to the power of 6, right? And then for this one, what do we do here is we multiply only the constant or the coefficient by coefficient. That means 2 times 4 is 8, and then a squared times a, that becomes a to the power of 3, and b times b squared is equal to b to the power of 3. That's basically your final answer for number 2. For number 3, we multiply the coefficient by coefficient, so we have positive 6 times negative 3 is equal to negative 18, and then x squared times x to the power of 5, we have x to the power of 7. That's your answer for number 3. For number 4 here, we have, how many b's do we have here? So we've got around 15 b, so we have 15 to the power b to the power of 15 here. Okay, for this one it is quite easy as well. We just have to multiply 3 times 3 times 3, negative 3, that becomes negative 27, and then we have x to the power of 3, x to the power of 4, x squared, so we have x to the power of 9. That's your answer for number 5. Let's try answering number 6 here. So we have, okay, this is a combination of two laws. We have power over power, power over power, and then product of a power. All right, so what do we have here is we just have to distribute the exponent to each of the factor there. So we have 2 squared x squared times 2, and then y cubed times 2. So the answer would be 2 squared x to the power of 4, and we have y to the power of 6. That's our final answer there. We could also make it into 2 to the power of 2, that becomes 4 x to the power of 4, y to the power of 6. Let's try number 11 here. So we have x to the power of 3 divided by x, that becomes x to the power of 3 minus 1. The exponent here is 1 automatically, identity law. That becomes x squared. Let's go number 12. So we have to divide 18 by negative 3. That becomes negative 6. And then c cubed divided by c squared is equal to c to the power of 1, or c. And then we have number 13. 9 divided by negative 3, that becomes negative 3, correct? Negative 3, and then a cubed divided by a is equal to a squared, and then b to the power of 5, b divided by b squared, that becomes b to the power of 3. Now I want you to pause the video and try to answer number 14. Alright, the answer for number 14 is negative 48 over or divided by negative 8, that becomes positive 6, because negative 48 divided by negative 8 is equal to positive 6. and then c squared divided by c is equal to c, and then d to the power of 4 divided by d is d to the power of 3. That is our answer for number 4. Now let's try to answer number 21 here. We have 8, and then x to the power of 0 is times 1, so that becomes 8. Our final answer for 21 is 8. Now how about number 22? Now remember, we can factor the negative here. Remember that then the exponent here is only for 3. It doesn't include the negative 3, because if it does include the negative 3, it should, if it does include the negative, it should look like this. Alright, not like this. Do you understand that? So that means the negative, the positive 4, the exponent 4 here does not include the negative sign there. So basically it becomes negative 1, right? We can factor out negative 1, and then that becomes 3 to the power of 4. Now 3 to the power of 4 is 81. So we have negative 1 times 81 is equal to negative 81. That's your answer for number 22. See, for number 23, this becomes negative 3 times negative 3 times negative 3, and then times negative 3. So negative 3 times negative 3 is equal to positive 9. Negative times negative is another positive 9. And then 9 times 9 is equal to positive 81. So these two are different. The answer for this one is negative 81. The answer for this one is positive 81. Now let's try number 27. We have so we have x to the power of xy to the power of 7 all over x cubed y to the power of 4. So what we're gonna do here is do the x first. So we have x to the power of 1 minus 3 times y to the power of 7 minus 4. So that becomes 1 minus 3 is equal to x to the power of negative 2, and then y to the power of positive 3. So we have a negative exponent there. So what we will have to do here is find the reciprocal. That becomes 1 over x squared times y cubed. So we're gonna multiply that. So we have y cubed over x squared. Now for number 28, we can just cancel x to the power of 0 because this is equal to 1, right? Now we have 6 times 3, that becomes 18. X times to the power of 5, the x to the power of 5, that becomes x to the power of 10. That's it. Then times 1 is still the same. Let's go to number 29. 29, we just have to distribute the exponent to everyone, correct? So that becomes 3 cubed s cubed, and then t 12 times cube times 3. So we have, what is 3 to the power of 3? 3 to the power of 3 is equal to 3 times 3 times t, that is 27. Then s to the power of 3, t to the power of 36, because 12 times 3 is equal to 36. That's your final answer for number 29. Now let's go to number 30. Okay, this is a mix of a lot of exponents, so we just have to distribute the exponent to every numbers there, or to every base. So this one, this one, this one, and that one. All right, so we have 3 to the power of 3 to the power of 5, m to the power of 2 times 5, n to the power of 7 times 5 over m to the power of 5. Okay, now so we can do, there is 3 to the power of 5, we have m to the power of 10, and then we have this n to the power of 35, and we have m to the power of 5. Now this is the only thing that we can do, right? So we have 3 to the power of 5, m to the power of 10 minus 5 is equal to 5, n to the power of 35. That's our final answer for number 30. Alright students, I hope you learned a lot today, and I'll see you soon. Goodbye and have a wonderful evening or good day.